এখন আমরা ক্লাসিফিকেশন অফ সেকেন্ড অর্ডার পার্শিয়াল ডিফারেনশিয়াল ইকুয়েশন এন্ড রিডাকশন টু ক্যানোনিক্যাল ফর্ম এই দুটো বিষয় নিয়ে আলোচনা করব। সো আমরা ফার্স্ট কিছু থিওরিটিক্যাল বিষয় আগে আলোচনা করব, দেন আমরা এই রিলেটেড বেশ কিছু প্রবলেম। সো generally our first recall is recall some basic facts, recall some basic facts. So what are the recall? Our first recall 1. This is about the characteristic root. Characteristic roots. So let R plus SS plus TT as f of x, y, z, zx, zy, this is equals to 0, be the second order semi-linear partial differential equation. Semi-linear partial differential equation. So here R means del to z dlx2, S is del to z del x del y, and T means del to z del y2, zx means del z del x, so this is the standard notation, or you can say the P, and zy means del z del y, or you can say the Q. So here we just consider a second order semi-linear PDE. Then the characteristic, the root of the equation, then the roots of the equation r lambda square plus s lambda plus t equals to 0 is called characteristic root. Characteristic root. This is in our case equation number 2. Now we try to know about the next recall. This is about basically characteristic root. Now we will memorize the recall 2 about the characteristic curve. Characteristic curve. So here we have considered second order semi-linear PDE. This is represented by equation number 1. So the characteristic curve of the equation 1 is given by dy dx plus lambda 1 equals to 0 and dy dx plus lambda 2 equals to 0. Now the question is, what is lambda 1, lambda 2 here? So where lambda 1 comma lambda 2 are the characteristic root, or you can say the characteristic root of the equation 2. Here you will see this is our equation 1 and the next one is our equation 2. So this part is basically equation 1 and this is equation. So this is quadratic equation in lambda. So you will get two values of lambda here. Maybe lambda equals to, I am considering lambda 1 and lambda 2 say. So corresponding these two characteristic root, we will consider two characteristic curve here. One is the solution of dy dx plus lambda 1 equals to 0, that first order linear ODE, and another one is dy dx plus lambda 2 equals to 0. This is basically second order. First order, but okay, with respect to the second root, dy dx plus lambda 2 equals to 0. This is another characteristic curve. Now we will discuss three important cases, and based on the case we will classify the second order linear PDE. So what are the consideration? This next we will come to the recall 3. We will consider three cases. So our first case, case 1, if s square minus 4rt, this is greater than 0. So now here our equation second order semilinear PDE. This is basically the general form RR plus SS plus TT plus FXYZ ZX ZY equals to 0. And here characteristic equation, this is R lambda square plus S lambda plus T equals to 0. Now here, if the discriminant of this quadratic equation in lambda, this is greater than 0. So here what will be the discriminant? So the discriminant b equals to b square minus 4s square minus 4rt. So that may be the three cases. One is it is greater than 0, or it is equal to 0, or it is less. Depending on the three cases, we will conclude three important conclusions. So first case 1, if s square minus 4t equals to 0, then that equation 1, this is equation 2, then equation 1, that means the semilinear PDE, that will be hyperbolic. That is hyperbolic. So this is our first conclusion in that case. Second, we also conclude the equation 2 has two distinct real root. Equation 2 has two distinct real roots. That means that is the root lambda 1, lambda 2, are the roots of this equation. These are characteristic roots. These are the lambda 1, lambda 2. So lambda 1, lambda 2 both are real number, and lambda 1 not equals to lambda 2. And from this we again conclude the number of the third conclusion, the number of characteristic curve, this is 2. So here we have, in that case we have two real family of characteristic. So that we can conclude for the first case. This is case 1. Now we will come to the case 2. If discriminant equals to 0. So case 2. If S square minus 4RT, this is equals to 0. Then what we conclude, our conclusion again, the equation 1, I said here is greater than 0, equation 1 is hyperbolic. Now the equation 1, this is parabolic. In nature. The second conclusion is the equation 2 has one real root, and this is basically the two real root, and the root are basically not distinct, so equal real roots. So equation 2, that means r lambda square plus s lambda plus t. The equation 2 has one real root. Say I am considering it, say lambda. So here lambda is basically equals to lambda 1 equals to lambda 2. So that means here two roots are real and equal. So in that case, that is two roots are real and equal. And the third conclusion is, so first is parabolic, it has one real root, and one real root here basically two roots are real and equal. That's why I am considering one real root. And you will see one real family of curves. So we have here one real family of characteristic curve. So now we will come to the case 3. That means if S square minus 4RT, this is less than 0. Initially I consider greater than, then equal, then less than 0. Then our conclusion is equation 1, that means the PD, semilinear PD, this equation 1, that will be elliptic. Equation 1 is elliptic. And the second conclusion is here the roots are not real. They are basically complex root and conjugate in pairs. So that means equation 2 has two complex roots. And here we can't say we can't get any kind of real family of characteristic curve. So what we get, we have two imaginary family of characteristic curve. Two imaginary family of characteristic curve. And hence we can say the number of real family of characteristic curve this is basically 0. That means there is no real family of characteristic curves. So in that way we can classify it is parabolic or not, or hyperbolic or elliptic, and we can conclude the number of characteristic roots, it is real or complex, and also we again consequently will conclude how many real family of characteristic curve exist in each case. Okay, so now we'll come to one important problem. The problem is here. The problem is given in CSIR NET examination June 2015 for part C. We have given a second order semilinear PDE. We need to consider the option is elliptic for x greater than 0, hyperbolic, elliptic, and hyperbolic for x. One is one option for x greater than 0, and other is for x greater than 0. So now the thing is how to solve this kind of problem. This kind of problem is very easy and it will take just only few minutes to solve. So now here what we will do, what is our PDE here? So our PD, semilinear PD, this is basically UXX plus XUYY equals to 0. What is our general form? Our general form is R plus SS plus TT plus F XY. In position of Z, we will write here U because it is given U. UXUY, that means PQ equals to 0. So this is our equation number 1. Where what is R? R is basically del 2U del x square. That means we will write UXX. S is basically del 2U del x del y. That means you can write UXY. Or if since it is continuous, you can write UYX also. And T is basically del 2U del y square. That we consider UU. P is basically del U del x, or you can write UX. And Q is here del U del y, that you can write UY. So that you already know. So comparing this equation UXX plus XUYY with the general form, and you will decide what is your R. So here capital R is basically 1. What is your S? Okay. So here S is basically 0. And what is your T? So here T is basically X. So now we will consider what is the characteristic equation. This is R lambda square plus S lambda plus T equals to 0. But here the discriminant, I will think about S square minus 4 RT. Okay, so what is S here? 0 square minus 4. R is 1, T is X. So that means it will be minus 4X. Okay. Now when it will be greater than 0 and less than 0? So this expression, so that implies S square minus 4 RT, this expression, this discriminant, that will be greater than 0 if X is less than 0. And it will be equal to 0 if X is equals to 0. And it will be less than 0 if X is greater than 0. Okay. So we conclude here S square minus 4 RT greater than 0. So in that case, what we conclude, using the different color here, in that case, in the first case, what we conclude, for that part we conclude, okay, this portion greater than 0 if X less than 0. So if it is greater than 0, that is basically hyperbolic. So here we can conclude hyperbolic if X less than 0. From that expression, it is parabolic if X equals to 0. And from that we can conclude the last one, it is elliptic if x greater than 0. So elliptic if x for x greater than 0, that option is correct. So obviously option C is false. And if x less than 0, it is hyperbole, that option D is correct, whereas option B is false. So that means the correct option is option A and option D. So this will be very easy questions that may be asked in graduation examination, or maybe you have asked in you have seen here the question has been asked in B.Sc or CSIR NET mathematical science. Okay. Now we will come to the next important problem. Consider second order PD. This is our second order PD, and you just compare this second order PD with the standard forms. What is standard form? Standard form. So this is basically RR plus SS plus TT plus FXYZ PQ equals to 0, where R equals to del 2Z del X2, S equals to del 2Z del X del Y, T equals to del 2Z del Y2. Now just to compare what will be your R. Here your R will be 8, and what will be your S? S will be minus 2, and what will be T? T will be minus 3. So now we will calculate S square minus 4 RT. That means 8 square minus 4 S square, sorry. That will be minus 2 square minus 4, R is 8 and T is minus 3. That will be 4 plus 96. Borrow 8 into 12, 96. So that means it will be 100. And obviously this is greater than 0. So that means what we observed, S square minus 4 RT, discriminant is greater than 0. So that means if the discriminant is greater than 0, just you see the case 1, it is basically the equation 1 will be the hyperbolic. So obviously we can conclude here, just this is equation 1. So here the given PD is hyperbolic in nature. Hyperbolic. So obviously option B is correct and option A is false. Now we will come to the general solution. So for general solution, what we will do, we will consider D as M and D dash as 1. So here our PD is 8, del 2Z del X2 minus 2 del 2Z del X del Y minus 3 del 2Z del Y square. So what we will consider del dx, that means that del Z del X. So that we consider for auxiliary equation, we will take as 1, and dy that will take as 1. So in that case, what will be our auxiliary equation? The auxiliary equation corresponding to the given PD, the auxiliary equation is 8m square minus 2m minus 3 equals to 0. If you solve this problem, so that just apply the Siddharacharya formula. So that will be 2 plus minus 4 plus 96, eta hobe tahole by 2a. So 2 into 8. So that means one root will be 3 by 4, another root will be minus half. Now you know, in that case what will be our general solution? Because it is a homogeneous PD, linear PD. So the general solution will be z equals to f of some function f of y plus first root m1x plus g of y plus m2x, where m1 and m2 are two roots of the auxiliary equation, say some constant, say am square plus bm plus c equals to 0, where a, b, c are constants. Okay. So what will be a general solution? Therefore, the general solution is z equals to f of y minus half x plus g of y plus 3/4x. And what is f and g? Where f and g are arbitrary differentiable or smooth function. So from that you just think about which option will be correct. Option C will be correct and option D is false. So that means here option B and option C is correct. So this is a very simplest problem in CSIR NET. So if you practice that kind of problem many more, so obviously you will think about, okay, you can expect one questions here. Obviously this is also important in M.SC and B.Sc courses of PDE. So now we'll come to the next important problem. The problem is here, okay. So next important problem, problem number 3. The partial differential equation del 2u del y square minus y del 2u del x square equals to 0 has option A two family of real characteristic curve, two family of real characteristic curve. Option B for y less than 0. Option B, no real characteristic for y greater than 0. No real characteristic for y greater than 0. Option C, vertical lines as a family for characteristic curve, for y equals to 0. And option D, branches of quadratic curves as characteristic for y not equals to 0. So this question is exactly asked in June 2013, and this is a part B question, and that question asked in CSIR NET. So maybe this kind of question you have asked in M.Sc course and graduation course. Okay, so now we'll compare this equation, the PDE, del 2 here the PD is del 2u del y2 minus y del 2u del x2 equals to 0. So this is basically our PD. We'll compare with the standard form. So this is basically RR plus SS plus TT plus F X Y U P and Q equals to 0. So you know what is R? This is basically del 2u del x2. What is small s? This is basically del 2u del x del y. Small t del 2u del y square. And P is del u del x. And Q is del u del y. And obviously u is a function of x and y. If we compare with this standard form, এর সাথে compare করা হয়, তাহলে তুমি দেখতেই পাচ্ছ তোমার r will be minus y, s will be 0 and capital T, this del 2u del y square, that will be 1. Okay. So now we'll calculate the discriminant of the characteristic equation, that is s square minus 4rt. So that means 0 square minus 4, r is minus y t. So this is basically 4y. Now we have many cases here. If y equals to 0, so what we get here? We get s square minus 4rt. This discriminant, this is basically 4. What we get? 4y. Now that will be greater than 0 if y greater than 0. It will be equals to 0 if y equals to 0. It will be less than 0 if y less than 0. So that means what we conclude? We conclude in that case, so what is our conclusion based on the different cases? If y less than 0, that implies s square minus 4rt, this is greater than 0, and that implies equation 1, that means that equation I am considering is 1 is hyperbolic. The PDE is hyperbolic. If y equals to 0, that implies s square minus 4rt, this is equals to 0, that implies equation 1 is parabolic. And if y greater than 0, so this is greater than 0, sorry. If y is less than 0, that means s square minus 4rt, this is less than 0, and that implies equation 1 is elliptic. Okay. So here what is exactly given? For y less than 0, two family of real characteristic curve or not. So if y less than 0, it is hyperbolic. So what is the conclusion here? When s square minus 4rt, see the conclusion. When it is hyperbolic, the equation has two distinct real roots, and we have two real family of characteristic curve. So in that case, we have two real family of characteristic curve. The parabolic, we have one real family of characteristic curve. For elliptic, no real family of characteristic curve. That means real family of characteristic curve, no real family of characteristic curve. That means the number of real characteristic curve is 0. Okay. So here, what is written? If y less than 0, two family of real characteristic curve. But it will happen only if y greater than 0. Y less than 0, no real. So obviously option 1 is false. No real characteristic curve is y greater than 0. No. If y greater than it has two real characteristic curve. But it is said no. So what we conclude here? If y less than 0, no real family of characteristic. But if y greater than 0, two real family. So y greater than 0, 2, and y less than 0, no. So it is, this option is also discarded. Now for case y equals to 0. Okay. So if y equals to 0, and another case is y not equals to 0. So now what we will do, if y equals to 0, so in that case, if y equals to 0, it will be parabolic, and in that case we have one equal root. Okay. So okay, we'll continue now. The characteristic root we will conclude. We'll try to find out the characteristic root. Characteristic root. So here the equation will be r lambda square plus s lambda plus t equals to 0. We will solve this equation, we will find out the root. What is r? Here r is minus y is 0 and t 1. So that will be minus y lambda square 0 lambda t 1 equals to 0. And from that what we can solve? We can solve lambda equals to plus minus 1 by root y. But okay, this is only possible if we assume the case y not equals to 0. Otherwise, if y equals to 0, that will be undefined. So lambda equals to plus minus y. So one root is lambda 1, that is basically plus 1 by root y. Another is lambda 2, that is minus 1 by. Now the question is, what are the characteristic curve? So the characteristic curve will, for that will be one is dy dx plus lambda 1 equals to 0. Another characteristic curve will come from dy dx plus lambda 2 equals to 0. So dy dx plus lambda 1, say 1 by root y equals to 0, and another is dy dx plus lambda 2 minus 1 by root y equals to 0. And from that, if we solve it, that will be 2y to the power. So just to think about dy dx, so dy by dy dx equals to minus 1 by root y, and here dy dx that will be 1 by root y. So that you can say y to the power half dy equals to minus dx, and here you can say dy y to the power half, this will be dx. So now on integration, what we will get? We will get here 2y to the power 3 by 2 by 3 plus x equals to c1, and here you will get 2y to the power 2 by 3 by 3 minus x equals to c2. So this is one characteristic curve, this is another characteristic curve. Okay. But if we assume y is equals to 0, so then here x will be plus minus c. In that case, x will be plus minus. So that means the vertical lines, so if y is basically 0 here, so just you put in the characteristic equation, if y is 0, so from that you can find out x equals to plus minus c, and the vertical lines are a family of characteristic curve for y equals to 0. So that means here option C is correct and option D is false. So option C is the correct option here. Okay. So now you need to think about the y equals to 0 that represent x equals to plus minus. Okay. Now we'll come to very recent questions. The question is asked in CSIR NET 16th February 2022, and it is also part B question. Which of the following partial differential equation is not parabolic? That means s square minus 4rt is basically non-zero for all x, y. The option A, x square del 2u del x del y minus 2xy del u del y plus y square equals to 0. Option B, x square del 2u del x square minus 2xy del 2u del x del y plus y square del 2u del y square equals to 0. Option C, x square del 2u del x square plus 2xy del 2u del x del y plus y square del 2u del y square equals to 0. And option D, x square del 2u del x square minus 2xy del 2u del x del y plus y square del 2u del y square plus x del u del x plus y del u del y equals to 0. So here what you will do, you will compare all the partial differential equation with the standard form. So what is your standard form? Standard form. So this is RR plus SS plus TT plus FXYU PQ equals to 0. So you know what is your R? R is del 2U del x square. S, this is your R. Capital R is the coefficient and small s is basically del 2U del x del y. Small t is del 2U del y square. P is basically del u del x and Q is del u del y. Okay. So now you compare for option A. This thing you will just calculate this discriminant s square minus 4rt. So for option A, your s is basically x square. Your R is x square S is minus 2xy and t is y square. So what will be s square minus 4rt? So that will be minus 2xy whole square minus 4. What is r? R is x square. The t is y square. So that means it will be 0. Okay. For option A, no. I have done option B. For option B, it is basically 0 for all xy. That means here for option B, this equation is basically parabolic. So it is parabolic. But what is asked here? Not parabolic. So that for that the option is false. Now what about option A? Option A here, r equals to x square, and that is this is the first order. So s is 0, t is basically 0. So s square minus 4rt, so that means it will be x to the power 4, and that is obviously greater than 0 for non-zero x. So it is not 0. So that means it is not parabolic. Not parabolic. Okay. So it is not 0 in general. So it is not parabolic. So option A is true. Similarly, for that option, you will see r is x square, s is 2xy, and t is y square. So s square minus 4rt. This is basically 0. So that means it is parabolic. But okay, in question it is asked not parabolic. Again, this option is false. Similarly, for the next option, your r is x square, s is minus 2xy, t is y square. And you calculate that s square minus 4rt. Again, it will be 4x square y square minus 4x square. Again, it will be 0. So that means it is again parabolic. So A, B, C, D all are parabolic, but here in our question it is asked not parabolic. So with option D. So option A is the only correct option. So this is one of the simplest question that has been asked in CSIR NET exam. So in that way you just practice this kind of similar problem, and you can obviously strike out the proper correct answer, and easily you will solve this kind of problem. So thank you so much.